Which of the following statements are true? We're given 3 statements here, and some combination of them could be true. Okay, the first statement: there exists a constant c such that log x is less than or equal to c root x for all x greater than or equal to 1. The second statement, okay, so probably what I'll do is I'll just go through these statements one at a time and see if we can confirm them or show that they're false. I won't read them all out before doing them. Okay, so there exists c such that log x less than or equal to c root x for all x greater than or equal to 1. I mean, this is true, right? In fact, c is equal to 1 should work. And I don't really think I need to go through much explanation. You can just plot the two of these things yourself. The intuition here is that, the logarithm function is much slower growing than the square root function for values of x greater than or equal to 1. I guess you would have to check when x is equal to 1, but like if I just choose c is equal to 1, log of 1 is 0, root of 1 is 1, so it's satisfied, and the log function is going to grow so much slower than the root function here, so that's fine. Okay, the second statement: there exists c such that the sum, goes from 1 to n of k squared is less than or equal to c n squared for all n greater than or equal to 1. So this is false. And this is false because when you add, I don't know what this is in closed form, but I know that you can derive it, but I know that it's cubic with respect to n. This whole thing has a cubic dependence on n as it grows, and the right-hand side, of course, is quadratic. And so no matter what constant you put here, no matter what fixed constant you put, for large enough values of n, this will be bigger than this. So that one is false. Typically, if you're adding up, if you add up consecutive integers, that grows quadratically. If you add up consecutive squares, that grows cubically. If you add up consecutive cubes, that grows as a 4th power. So it's good to know that. Okay, and the third statement: there exists c such that sine x minus x in absolute value is less than or equal to c x cubed in absolute value for all real x. So this is false. Wait, is it? Yeah, this is false because I mean, sine x minus x, like, it's clearly sort of alluding to the Taylor expansion of sine x, or the Maclaurin expansion around, like the expansion around 0, which is a power series that starts with x, and the next term is a power of x to the 3, and then it's x to the 5, and so on. But wait a minute, hold on. No, this is going to be true. I was thinking in my mind of graphing things. Yeah, I'm wrong here. This one is going to be correct. I was thinking in my mind, back in the days when I was learning about Taylor expansions and graphing them on my little handheld calculator. You graph the first order expansion of this, then the third order, fifth order, and so on. And of course, the error of that gets, for any fixed order, the error starts to get extremely large as x gets farther away from 0. But that's not what this is asking. This is not asking for, the difference between sine x and, what is it asking about? Oh my goodness. I mean, here's another way of seeing that this one is true. Just plot this. I'll only do it for positive values of x, but instead of plotting sine x minus x, I'll plot x minus sine x, and x minus sine x looks something like this, right? Which grows linearly as a function of x. The large growth is linear, which is certainly going to be less than cubic. And if I plot a cubic, I can clearly choose this function c. Just choose c to be 100. Cubic will be like that. So sine x minus x is going to be bounded by this cubic. I mean, you can probably revert to a precise statement of Taylor's theorem, like the remainder theorem. I can never remember exactly how that statement goes, but we clearly have the first order approximation to sine x here, and that's going to be bounded by something that has to do with, I don't know, maximal derivatives of sine x or something like that. I don't remember. But yeah, this is sort of a more direct way of seeing that sine x minus x will be bounded by this cubic, is just actually figuring out what the graph of this thing looks like. So I hope that there's an option here to choose 1 and 3. Yeah, it is. That's option D. Almost stumbled into something incorrect here. I almost said option B, 1 only. Not sure exactly what was going wrong in my mind here, but yeah, I'm happy that I just thought about this a little longer and what the graph of this thing looks like. Cool problem. Thanks for watching.